Greetings to all of you. In today's session, we are going to discuss about the intermediate chemistry on the competitive examination level on the international floor, national India floor, and on Telangana floor. This kind of explanation will be helpful if you are preparing for any competitive exams on the international examinations if you are writing, and the national level exams like JEE Advanced, JEE Mains, and NEET chemistry. In the Telangana level, it will be MSET chemistry, Andhra Pradesh MSET chemistry. For all these, the detailed explanation will be very much helpful for you. Let's enter into our today's session. Here, the question number 1 is given from IUPAC nomenclature. IUPAC stands for International Union for Pure and Applied Chemistry. Select the correct IUPAC name for the following compound. Organic compound is provided to you where we are having two terminal functional groups, namely bromo and chloro, and one methyl side chain is there. So for this chain, we have to mention its IUPAC name. Here, in order to give its IUPAC name, there are 4 options. We have to find out the right answer. So here, correct answer will be 1 bromo, 4 chloro, 3 methyl butane. Let's see how can we get this answer exactly. In order to get that one, we have to go for the IUPAC rules. According to IUPAC, the rule number 3 will be, after applying the first and second rules, alphabetical order will be considered if more than one functional group is present in the given compound. So alphabetical order means what? Here we have bromo and chloro. Bromo for B, chloro for C. So that we have to go for least numbering. That means B will come first over C. That's the reason why. So bromo will get first priority over chloro. So that 1 bromo, 4 chloro, 3 methyl butane. Okay. The numbering, if we are starting numbering from this end, this will be the wherever corner is there, that is mentioned with the carbon atom. Carbon number 1, carbon number 2. Carbon number 3 contains any other side chain, that is methyl. So the 3 methyl we have to mention. On 4th carbon, another group is there, that is called chloro. So that 1 bromo, 3 methyl, 4 chloro, and the parent chain will be 4 carbon length, so that you can mention butane. So correct answer will be 1 bromo, 4 chloro, 3 methyl butane. This is in accordance with the rule number 3, where you can find the alphabetical order if more than one functional group is present over here. This is the right answer for question number 1. Let's move on to question number 2. And the correct answer is provided over here. That is 1 bromo, 4 chloro, 3 methyl butane is the right answer for the given IUPAC nomenclature. Move on to question number 2, where all the following compounds are said to be diamagnetic except one compound remaining, all are said to be diamagnetic. That means, sorry, diatomic in nature. Diatomic in the sense, two atoms got joined themselves. Okay. So, except one compound remaining, all are diatomic only. Means joined by 2 atoms only. Fine. So, among all, water will be the correct answer. How can we get this water as a correct answer? Let's move on to explanation part. Here, if you see oxygen, oxygen is said to be diatomic, where 2 oxygen atoms are joined by double bond. One is said to be sigma bond, second is said to be pi bond. And this is called as homoatomic molecule. Homoatomic means the molecule which is made up of same type of atoms is called homoatomic molecule. And moreover, only 2 atoms are there in this O2, so that we can say diatomic as well. Okay, so this is a diatomic molecule. And move on to carbon monoxide. If you see carbon monoxide, carbon atom is mentioned with this black color, and red color lobe indicates oxygen, and both are joined by triple bond. Right. And here one lone pair, another lone pair is mentioned with the Lewis dot structure. And if you see carbon oxygen heteroatomic in nature, and moreover, we have 2 atoms only. Hence, it is also the kind of diatomic molecule. Move on to another one, sodium chloride. Sodium chloride is a kind of ionic compound where transfer of electrons from one atom to another. And here sodium is losing electron, hence acquires positive and the chlorine is gaining electrons so that mono negative ion will be generated. In a place, Cl minus is the right representation for sodium chloride ionic compound, and it is said to be diatomic molecule. So this is also diatomic. If you move on to water, water is a triatomic in nature where oxygen joined with the two hydrogen atoms. If you see, so one oxygen and the two hydrogen atoms are there. So it is the bent molecule with the sp3 hybridization phenomenon, and it is called tetrahedral geometry, and bent shape is acquired by the water molecule, where we can see three atoms are joining with the covalent bond, and it is said to be a triatomic in nature. For the given question, diatomic molecule, oxygen is diatomic, carbon monoxide is also diatomic, sodium chloride ionic diatomic molecule, but water is a covalent triatomic molecule. So that right answer will be 4. For question number 2, option number 4 is the right answer. Move on to question number 3. Question number 3 is given from the previous JEE Advanced Question Paper 2023. Consider the following reaction scheme and choose the correct option for the major product Q, R, and S. It is the stepwise reaction. Series of reactions are carried over here. You have to identify what is the outcome at the point Q, what is the outcome at a point R, and final product S. Let's see. Starting material is styrene, treated with B2H6 is called diborane, and further treated with alkaline medium called sodium hydroxide. Hydrogen peroxide is provided, and water is the aqueous medium is given for this. Whenever all these are treated, styrene converted into the product called P. This P can be treated with chromium trioxide and sulfuric acid. This is known as Jones reagent. And another, after treating this Jones reagent, next step will be chlorination in the presence of red phosphorus. This is called Hell-Wohlert-Zielinski reaction. And further hydrolysis, water medium is provided. So after all these reactions, P got converted into Q. This P again, we have to go with the P again. We have to remember what steps we are following. Don't messy with the Q. So here P is taken as a starting material again, and thionyl chloride, it is the chlorinating agent. The chlorine will be given over here. So SOCl2 is provided, thionyl chloride, and followed by sodium cyanide. It is called sodium nitrile as well, which used to give the Cn minus nucleophilic reagent, followed by hydrolysis under acidic conditions. Upon treating with these many reactions, P will be converted into R. R will be treated with the concentrated sulfuric acid, being it is the dehydrating agent. The final product will be dehydrated one. So these many reactions are there. We have to identify what will be Q, R, and S. Let's enter into the explanation part. How can we achieve all these reactions? Here, these many options are provided. Q, R, and S will be given these many types. Among all, the correct answer will be B, where Q will be alpha chloro, what we can say, phenyl acetic acid, and R will be one of the carbon got increased, so that we can say propionic acid. Phenyl propionic acid will be R, and this will be condensed, where dehydration carried and condensation, so that we can say cyclization as well. And here 5-membered ring got generated as the final product with the carbonyl ketonic functional group. So this will be S. Let's see how can we get these many answers. For that purpose, first of all, the starting material taken for this reaction will be styrene. Vinyl benzene is called styrene, where carbon-carbon double bond is there. This vinyl benzene, upon treating with the diborane, B2H6 is called a diborane, it will be added on double bond hydroboration reaction. This is called a hydroboration. This hydroboration is proceeded in the presence of hydrogen peroxide. Hydrogen peroxide is the catalyst which used to give anti-Markovnikov addition product specifically, because hydrogen peroxide is the reagent which proceed the reaction mechanism through anti-Markovnikov rule, where negatively charged reagent, that means OH minus, will be attached in the carbon having more number of hydrogens. Here, if you see CH, this is having only one hydrogen, but terminal carbon is having two hydrogen atoms. That's the reason why terminal carbon will be added with the nucleophile. Here the nucleophile is OH minus released from this sodium hydroxide. So that OH minus will be attached on the terminal carbon in accordance with the anti-Markovnikov rule in the presence of hydrogen peroxide, right? That's the reason why the P product will be CH2, CH2, OH. OH means nucleophile attached in the terminal carbon, right? So this is product P. This P further treated with chromium trioxide sulfuric acid. This combination is called Jones oxidation. Jones oxidation will give rise to CH2OH into COOH. That means oxidation, right? So this alcohol is converted into carboxylic acid and it is named as 2-phenyl acetic acid. The name is 2-phenyl acetic acid. This is simply oxidation process under Jones reagent, chromium trioxide, sulfuric acid together known as Jones reagent. Further, this carboxylic acid is treated with chlorine in the presence of red phosphorus. Chlorine red phosphorus is the reagent for the reaction called the Hell-Vollard-Zelinsky reaction. Hell-Vollard-Zelinsky reaction is very specific for alpha halogenation. The carbon which is adjacent to the functional group is called alpha carbon and the hydrogens are said to be alpha hydrogens. These alpha hydrogens are replaced with the chlorine atom, simply said to be substitution, right? So that we will get alpha chlorocarboxylic acid. It is named as 2-chloro, 2-phenyl acetic acid. This is the Hell-Vollard-Zelinsky reaction, reacting with chlorine under red phosphorus conditions, right? So here, this is the product called Q. So P is known, Q is also known. Move on to next step. Starting with P, we have to start with P where we are having CH2OH. This alcoholic compound is treated with thionyl chloride. SOCl2 is the halogenating agent. It will replace OH with chloro so that hydroxy compound now converted into halogen compound. It is named as 2-chloroethyl benzene. 2-chloroethyl benzene. So this is compound formed and further treated with sodium cyanide, also known as sodium nitrile. This nitrile again nucleophilic reagent where Cn minus will replace chloride. Chloride when replaced with Cn, we will get a nitrile compound. 3 carbons taken into the consideration for naming so that propane will come over here. 1 carbon got raised. This is called homologation. Chain length got increased. Fine. So 3-phenyl propane nitrile got generated. 3-phenyl propane nitrile further subjected to hydrolysis. Addition of water is called hydrolysis. Always nitriles upon hydrolysis, the subsequent product will be carboxylic acid. COOH is called carboxylic acid. Simply, Cn is converted into COOH upon hydrolysis. Always this is a reaction under water conditions, aqueous conditions, right? So that 3-phenyl propionic acid will be formed. This is the expected product R. One of the product what we are expecting is 3-phenyl propanoic acid. After getting this R, we have to move on to final product. Upon treating with dehydrating agent called concentrated sulfuric acid. Concentrated sulfuric acid removes water and subsequently cyclization process got carried and stable compound will be generated 5-membered ring with the ketonic group over there, which is named as 2,3 dihydro, 1 hydrogen, inden, 1 one, right? So inden 1 one will be generated. This will be product S, right? This is the series where we have to move on. So all these are the reagents. We have to know the specificity of the reagent, what reagent will give which product, so that it is very obvious to get the final product, right? Let's have the glance over here. Hydroboration under peroxide conditions gives the product called OH on the terminal carbon. This OH further oxidized to carboxylic acid with the chromium trioxide. And this carboxylic acid will be treated with chlorine under red phosphorus, so that alpha chloro will be generated. And that P is the taken as the starting material, treated with the halogenating agent called thionyl chloride, and we will get chloro compound. Chloroalkane will be generated. OH will be replaced with chloro, and subsequently treated with the sodium nitrile. So chloro will be replaced with cyanide, and finally treated with water. Cyano or nitrile, always hydrolysis gives carboxylic acid as the final product, so that we will get acid. That carboxylic acid finally treated with the dehydrating agent, removal of water takes place, and subsequently cyclization ring closure reaction got carried, which is also called a fusion reaction, so that we will get ketonic functional group over here. This will be the series of reactions, and all will be satisfied in the option number B. For question number 3, option number B will be the correct answer. Move on to question number 3. Sorry, question number 4. In the question number 4, this is the question given from inorganic chemistry. Starting material is unknown. This is only the unknown compound given, which is the metal halide. This metal halide, upon treating with alkaline condition, that is aqueous sodium hydroxide, will be treated with metal halide. White precipitate is formed and filtrate is formed. Nothing is known here. Metal halide is unknown, white precipitate is unknown, filtrate is also unknown. Only reagent name is given, right? So from remaining steps, we will get the clue in order to find out what will be the entire series of reactions, right? So this white precipitate P, unknown compound, as of now it is unknown only. Further treated with aqueous sulfuric acid and lead oxide. Whenever aqueous sulfuric acid and lead oxide got treated, again unknown compound is formed, that is a colored species in the solution. That will be the colored species, right? So colored species, if you are getting colored species, remember one thing always, if any compound is having unpaired electrons, then DD transitions are possible, then color can be appeared. And another possibility to get the color is charge transfer, right? Ligand to metal or else metal to ligand charge transfer also causes color to the given compounds. So being it is the metal halide, so the color may be due to DD transition or else charge transfer, right? So this is the kind of clue we will find over here. And we have to go for here, we will get the confusion. This is not the continuation, rather we have to take this Q. Filtrate can be taken over here. That filtrate upon treating with the manganese oxyhydroxide, MnOOH taken twice is said to be manganese oxyhydroxide, fine. And in the presence of concentrated sulfuric acid and warm conditions, mild heating conditions are provided, and final product will be Y. The question is, in the scheme given below, X and Y respectively are, X is to be determined and Y is also we have to identify. Here, the actual case we got over here. So actual, what exact clue we got over here, that is, gives a blue coloration with the potassium iodide starch paper, right? Starch is the indication for the liberation of halogens. Okay, so starch, whenever it is treated with halogens like iodine, it will give blue color complex. Chlorine, it will give blue color complex. Bromine, it will give blue color complex. So here the answer will be starch paper will give blue coloration. That indicates Y must be halogen. So if you look at all the options provided, In the A, we have bromine, chlorine, chlorine, HOCl. So we can discard this one. HOCl may not be the right answer. There is a possibility to get A, B, C, any one of these, right? Let's solve this problem. Here, the compound can be analyzed in the manner whenever any compound of manganese and they mentioned with metal halide, right? So manganese chloride, let's take manganese chloride upon treating with hydroxide, that means sodium hydroxide. Here we are having aqueous NaOH, right? So here sodium hydroxide, if you are taking, finally it will be turned into a manganese hydroxide, which is white colored solid. That is required, what actually we require over here, that will be P, right? White color solid will be manganese hydroxide. If you see, you can clearly observe at the bottom of this test tube, right? So here step by step we solve this problem. Metal halide will be taken, aqueous sodium hydroxide will be added, white precipitate and filtrate. Okay, so manganese chloride, upon treating with sodium hydroxide, manganese chloride turned into manganese hydroxide, which is a white color precipitate. What exactly mapping with this? And whenever manganese hydroxide is formed, leftover will be chlorides and sodium, so that sodium chloride will be formed, which is aquated solution, so that we can say it is the filtrate. Q will be the filtrate. It is the dissolved salt in the water is called filtrate. Fine. And this P is nothing but precipitate, what we are taking here. That precipitate can be treated with aqueous sulfuric acid, lead oxide, and heating is provided. X will be formed, that is a colored species. Manganese hydroxide treated with sulfuric acid and lead oxide. Whenever sulfuric acid and lead oxide is treated, manganese hydroxide will be converted into permanganate. This is converted into permanganate. Here, if we observe, manganese exists in +2 oxidation state, whereas final product is having +7 oxidation. Permanganate is having +7 oxidation state, so that +2 to +7 increase in the oxidation state, which is called the oxidation process. In the presence of these sulfuric acid and lead oxide, the center of the mechanism involves oxidation, so that manganese hydroxide is turned into permanganate, right? So warm conditions we are providing over here, and purple color solution will be provided. This will be the step number 2. Move on to step number 3. This will be the final one. So we have to go for this Q. Q is called a filtrate. That filtrate will be taken. The Q filtrate will be taken and treated with manganese oxyhydroxide concentrated sulfuric acid. As already we know, manganese is the kind of oxidizing agent, so that whatever halide is there, sodium chloride is formed over here, and that will be oxidized into chlorine gas. Cl minus is converted into Cl2. That is the oxidation process again. Here the condition provided called a warm condition. And here is the test where if you are dipping this, if you are dipping starch paper, potassium iodide starch paper into this chlorine, aquated chlorine one, so that blue coloration we can clearly notice, right? So this is a kind of information which is gathered from the library text. Thank you very much. And move on to another question number 5, where it is question which is already provided in TCS Ion CAE. It is the question given in the competitive exam, a junior lecturer competitive exam, so that it will be helpful for the aspirants of competitive exams and those who are writing the entrance exam in the intermediate level. It is collected over there. Which of the following element has 2 electrons in its valency shell? 2 electrons containing species among all the metals. All are said to be metals only, so that we have to find out. Hello? Hello? Hello, madam? అనుకోకుండా టచ్ అయినట్టుంది పాపం. టచ్ చేయించినట్టుంది. మిస్డ్ కాల్ ఉంది. Sorry for disturbing. Here, which of the following element has two electrons in its valency shell? Valency shell stands for outermost shell, right? Any element's outermost shell is said to be valency shell. All four metals are provided over here. One is chromium, manganese, calcium, and lithium. Among all, two electrons containing species we need to find out. If you see the chromium, it is the D block element where atomic number of chromium stands for 24. And in this chromium, valency will be 2. Valency is nothing but ability to bind with other atoms. And valency electrons are found to be 6, right? So valency electrons, the actual question is a valency electrons only. A number of electrons in the valency shell only. So here 6 electrons are there. So that chromium will not be the right answer, right? So let's count how can we get this 6 electrons valency shell of chromium. Chromium outermost shell configuration will be ns1 n minus 1 d5. That means what we can say 3d5 4s1 is the correct outermost shell configuration. 3d5 4s1 5 plus 1 total 6 electrons will be there. All these 6 are said to be valency electrons of chromium. Move on to second option. Second option is manganese. No, manganese atomic number is 25. Just ascending from chromium to manganese, one atomic number got raised. Here it will be 25. So that valency electron count will raised by 1. So that 7 valency electrons will be there. Let's count how it will be. 4s to 3d5, 4s to 3d5, 2 electrons in s orbital, 5 electrons in d orbital. So that 5 plus 2, 7 electrons will be there. Manganese is having 7 valency electrons. This will not. And move on to calcium. If you see the calcium atomic number will be 20 and outermost shell configuration is ns2 np6, ns2 np6, and what will be the outermost calcium is the kind of second group element, second main group element. We can write its outermost configuration as ns2 only. ns2 means what will be the shell? 1s2 2s2 2p6 3s2 3p6 4s2, right? 3s2 3p6 4s2. So that 4s2 will be the outermost electronic configuration of calcium. Fine. So here number of valency electrons of calcium will be 2. Its a symbol will be Ca. Atomic number will be 20. Valency means ability to bind with if you see the calcium chloride, Cl2 will be there. Calcium hydroxide OH taken twice will be there. That is called its binding ability. Fine. Valency electrons are 2. Means number of electrons in its outer shell. If you see this valency electron here only 1. Here another 1 is there, 2 valency electrons you can find. This will be the correct answer, calcium. Move on to lithium. Lithium is the first main group element. Its atomic number of lithium will be 3. Li will be the atomic symbol and valency table to bind one atom, and valency electrons are 1 only. If you see lithium, second shell is containing only 1 electron. Let's see the electronic configuration of lithium. 1s2 2s1. So that 1 electron is there in outermost shell. For the question number 5, 2 electrons in valency shell will be accorded for calcium. For question number 5, option number 3 will be the correct answer. Move on to question number 6. It is the kind of question provided with the multiple options. We have to find out which is the correct one. Which of the following are principles used in filling of molecular orbitals? In order to fill the molecular orbitals, what kind of principles are presided? One is it Auber principle. Second is Pauli's exclusion principle. Hund's rule of maximum multiplicity. These many are provided which are required in order to fill the electrons in the molecular orbitals. Let's see. The correct answer will be 1, 2, 3. All three are required. How can we justify this answer? In order to get that, Auber principle can be defined over here. This is called Euler diagram, where orbitals are filled in accordance with their increasing order of energy. Let's see. According to the Auber principle, electrons are filled in the orbitals, increasing orbital energy levels. Lower energy orbital will be filled first. Latter higher level orbitals got filled. Okay, if any new building is there, first of all, first floor will be occupied, later on second floor, later on third floor. In this manner, here Auber principle can be compared, we can say. Fine. And it clearly explained with the Euler's diagram, where one is orbital get filled first, later on 2s, 2p, 3s. This is the way increasing order of energy. Increasing energy levels, so increasing filling of electrons are possible, called the Auber principle. Move on to Pauli's exclusion. Pauli's exclusion principle gives that no two electrons in an atom exist in the same quantum state, right? Any two electrons, if taken, you can't fill two electrons in the parallel fashion, right? Both are with the clockwise rotation or else anti-clockwise movement as well. There is only the provision, one is in clockwise rotation, another anti-clockwise rotation will be there. This will be the right representation for Pauli's exclusion. Then only all four quantum numbers got satisfied. No two electrons are having all four quantum numbers the same, right? So four quantum numbers are namely, one is called principal quantum number, second is called azimuthal quantum number called angular quantum number, third is called magnetic quantum number, and fourth is called spin quantum number. These four quantum numbers should be different for all the electrons whichever present in the given element, right? Principal quantum number is denoted with N, and L is for angular or azimuthal quantum number. M denotes what? Magnetic quantum number. MS means spin quantum number. Fine. All four should be different. Then only they exist in the stable form, right? Either both are in the upward direction or else a downward direction. Both are not yet all preferable. One should be up, another should be downhead. Then only that is the accepted kind of representation in accordance with the Pauli's exclusion, right? Then only all four quantum numbers will be different. Move on to third one called Hund's principle, Hund's rule, right? According to the Hund's rule, what we can say, Hund's rule states that in the orbitals of the same subshell, electrons filled singly first, later on pairing will be started. If you see this, whenever one s orbital is there, one electron will be filled and the second electron will be paired over here only. 2s, one electron followed by second electron. If you are going with the 2p orbital, 1, 2, 3, the fourth electron must enter into the first orbital like this, but not like this. So this kind of representation is perfectly wrong, right? After getting singly occupied, then only pairing of electrons are possible. That is called Hund's rule or Hund's principle. And this is also clearly explained over here. So if you are moving like this, getting more number of electrons in the 4s2, 3d, 1, 2, 3, 4, 5, 6 electron system, that is the iron element, metal, what we are taking is the iron. One s orbital is occupied with the two electrons. First one electron got filled and the second electron again got entered into this, because here this energy level is the lowest one. And later on 2s orbital got filled, 2p orbital also completely filled because we have how many 26 electrons over here, so that 2p is completely filled, 3s is also filled, 3p is also filled. All these are called inner shells. Now valency shell configuration will be 3d, where electrons are six electrons can't be taken one all the electrons in this up and the downward direction. Rather, we have to fill in this manner. 1, 2, 3, 4, 5. The sixth electron entered into this d orbital where pairing is possible. All the orbitals singly occupied first, later on pairing of electrons are possible is called a Hund's rule. Fine. All three are perfectly explained in order to mention the filling of molecular orbital, so that all three are the right answer. For question number 6, option number 4 will be the correct answer. By this, we entirely completed the session for the day, and this is the entire explanation for the content whichever present in the intermediate level. Hope this will be very much helpful for your entrance examinations, and who are aspiring for any competitive exams you are writing in different regions, so that I think this will be helpful. I'm requesting you to like the channel, comment over here whatever you are really excited for and really interested about. And if any clarification you need, that also you can comment over here, and share this channel with any aspirants whichever need this actually, and subscribe for more such kind of updates in order to get in the continuous manner. Thank you very much. Thank you one and all for patient listening.